will replicate your logic. So whatever you write in the logic gets replicated. So change the tab from IO planning. So on the corner there is a default tab. Change the tab to IO planning tab. So change the tab now. IO planning tab. So IO planning is nothing but a pin assignments. IO means input and output assignments you need to do, right? IO plan. Click on it. So below you will get the IO ports. Below. IO ports. Once you click on IO planning, so you will get the below the tickle file you will get the IO ports. So I click on the IO planning, so you will get the IO ports. At the bottom you will get IO ports. Now how many ports are there? There are 5 ports. So this number you will be knowing because whatever you declare in the program, input outputs, that many bits. So it's a single bit I am declared, so it is easy. Multiple bits means you will have more number to assign. Okay. So it's a single bits. Expand it. Scalar ports, all are scalar. Scalar means single. Vector means you will have multiple ports, right? So ABC is input, some carry is output. So what we will do, we will assign the pin numbers for this. So in the packaging pin section, we need to assign. So we will assign A, B, C. So take the board. On the board it is printed. So it is also one of the way where you can assign the pin numbers. Take the board. There is a board, right? In front of you, there is a Zybo board. Okay, just open it. So there are 4 switches. Assign the switch numbers. So there is a board in the below switch is showing you the numbering. Okay. Assign the number. So assign the number. The first switch is G15. So I'll assign the G15. G15. The second one is P15. Assign it. And then is W13. Please assign it. The voltage standard is LV-CMOS 33. Browse it, LV-CMOS 33. 33 means 3.3 voltage standard. Please browse it. Assign. See on the board it is there. Can you verify it? See this is the switch. And below is G15, C15, W13. Assign in the same way. It is there on the switch, you can see. Right. Similarly, you can see all the switches. So LED also it is printed. Please observe it. On the top there is a LED section. So voltage standards you need to assign. Next is IO standards. Here, assign it to 30. LV-CMOS 30. Assign one by one. IO standards. Expand it. expand it. Then you can assign it. LV CMOS that is. See. K80, P60, right? K80, P60, K90, right? And next LEDs are M40 on the switch. Give M50. LED output is the LED. You need to see it in the LED form. M50. So whatever the direction voltage standards are A, B, C in ಯಾವ direction ಬೇಕು ಆ direction. G15 is output LED. M sum is M15. Depend upon the board involved. You assign the pin numbers. What is standard? Standard. Set the IO standard. Like you need to assign for switch, LEDs, push buttons. IO standards you need to assign. See where you will get the IO standards. You can go to the website and you can search for ZYNQ Z7 pin configuration file. Or you will get I will share you this file, constraint file. So where in this it will mention you the pin configuration ZYNQ, right? So you can see ZYNQ file. So in the ZYNQ file you have the pin number for switch and the IO standard is LV CMOS 30. That's why I am asking. So this you can see the file and you need to understand. So you can Google it, a pin configuration file for ZYNQ Z7. ZYNQ Z7. So you will get that file. So this is a file. You have to Google it. So you get a file like this. So where you can know what is the clock pin number, what is the IO standards. It will be in the GitHub also. This file is available. So go to the software. So please assign all the things. It should not show any red color markation. So it should not show any red color indications. Okay, Control S to save the file. So once it is done, Control S you can view, because we have assigned in the GUI. Just view OK and it will ask for the name. You understood, right? Control S to save the file. You have done, right? So Control S. Yeah, just view OK. See, you are saving the constraint file. This is a constraint file. Okay, or pin configuration file. You can call it as a pin configuration constraint file. Give some name. Any name you can give. There is nothing to worry. No need of any extension. The extension is written there. It is a XDC is a file extension. XDC is a file extension. Okay. So file type is XDC. File name you give and give OK. So it is saved in the file. Go to the source section now. You know how to go. If I turn somewhere to go into the source tab. Source tab. Minimize this. There is the source tab. Everybody can go to the source tab. You can see source tab. Below that there is a constraints tab. Give some names. Any name. Just give OK. Go to the source tab. Constraints. Expand it. Double click on the constraint file. So I think you got a constraint. Everybody got a constraint. Double click on the constraint file. So this is the constraint. Go to source file. Double click. But so it should always say even number, right? It should not be odd number. That is also one thing. You can see always it should be even number. Why? 10 lines is there. 5 pins, 10 lines. one pin number, two lines, one for pin, one for voltage. So it's very simple equation. Okay. Should always one port, two numbers will come. Set package pin J15 is a packaging pin number is assigned. Then the voltage for the respective. For A, there is a voltage for a package pin. One line for package pin, one line for voltage. Like that, you should have even. Should not be odd. If anything is issue is that you will get error. So you will get an error once you have a pin configuration issue, because the board will have to understand properly. If you have one line you missed, then it will throw an error. Implementation failed, bit stream failed. Understood? Because the board without voltage it cannot allow you, without pin number it cannot allow to implement on the board. So it is all relates to board. So you cannot
compile before the
I think it's already done. One time you have to do that. So you can simulation and getting it's done. There is no point in modifying it. So the tool is accepted. No compilation. So error is that now it throws in the implementation. Okay, run implementation. Click on run implementation. Yes. So it will give a dialog box. Give OK. So whatever it pops up, it just give OK. Okay, you give. Yes. Yes. Yes, you give. Yes, you give. Okay. Okay. So wait for it till the implementation completes. So understood, right? The procedure is simple. So it will be in the corner where you can see all the things. On the left hand side, the flow navigator, you can see all the steps one after the other you need to do. You have to wait. You have to see the check mark. Okay. Till the implementation completes. Port change. Port change. See, once it is done, click on open the implemented design, right? Give OK. Click on open implemented design and give OK. So you can able to implement the design, you can open it. Just give OK. Yes. So it will open the window. So you can see the device, right? So yesterday you saw the Kintex board, right? All are having the banks. So here, having all the banks is not FPGA. Few are FPGA, few are ZYNQ, right? So this section which is not showing you, that is a ZYNQ. That is a ARM processor. ARM processor. So the next lab what we will do, I can show you with the ARM processor. Okay. So now we didn't do any ARM, right? So we have written some code. The code is definitely going to be in the FPGA. because ARM will not understand the Verilog code. So our FPGA will understand the Verilog. So ARM will understand C code. Okay, so different languages. So we will know that, we are sure that we are going to implement it on FPGA. So we will read on FPGA. So go to the source tab. Go to the source tab. Then adjacent to the tab is a netlist tab. Click on netlist tab. Expand the nets. Expand the nets. Netlist tab. Control A. Select all the nets. Control A. Yeah. So you can see on the device. It's showed you. Zoom and see there. Drag one box there. Nearby. Control A. Control A. Again nets. Control A. Zoom fit. Drag a box there in the code. Yes, another box again. Yeah. You can see, right? Yes, that's how the ports are actually. Whatever you have mentioned the ports, you can view that. So you can drag the box there. You can visualize it. You can visualize it. So your logic has been implemented. You can go for generate bit stream. See, you want other way to see. You can see here. So you can click in the next section. There is this is by this way I am routing. See here. You didn't get this way, right? To do this, you click here. Routing this. Click on that icon. So you are getting a proper way, right? Just normal way. Neatly it has been shown. Nothing difference. So just showing in that way, and now you can see that with a good way. So proper routing thing situation. So it is properly going in the straight lines. It will go. So earlier it is showing like a straight lines. So now it is showing with a decent. So LUT, took the LUT, okay, to implement the logic. Okay. So now you can generate the bit stream. So you understood, right? So it is optimized. Agreed? It is optimized, right? So it is took one LUT which is near to the IO pins, and it is placed in the very corner, right? So it is not wasted. See, entire banks are LUTs, okay, but it took the nearby LUT, okay. So it is not going to waste the resources. So it is having a plenty of resources. Some 40,000 LUTs are there, but it is used only one LUT, and which is very near it, the IO banks. So if you want to see the power import, you can click on the power imports in the implemented design. Go to the implemented design section. Okay, there is a below schematic is there. You can click on schematic. The same schematic you can view. The report power. If you click on report power, you can see the report power. So you get a tab at the bottom. So you can see this is the report power. You can able to view that is utilizing the 2.669 watts. Okay, because it's very high, because you are getting the data from the switch. Switch is at the external section, and the chip is the inside one. Through the chip, through the switch, you are connected to the chip. So this switch utilizes 3.3 volts. That's why the voltage is power is consuming more, but it's very less. Still it is less. Total on chip power is 2.875 watts. Right? Just you. Right, power you got it. So now we can click on generate bit stream. Just be okay. So it will generate the bit stream. Now I will show you. After the completion of generate bit stream, we will connect the board and we'll see the output. So once the generate bit stream complete, it will show you a window. Bit stream complete. Okay, wait for it. Just wait once the completion has been done. On the top corner, you need to start. So once what is the status? Once it finishes, so you can able to do. So understood, right? Any logic you can write. So it's what we showed is simple one. So you can Google it. What kind of logic you want, you can taking the source code from the online cable. So once the bit stream is complete, it will be a window. So like this. So you can click on Open Hardware Manager. Just click on Open Hardware Manager.
Outside.
Hardware Manager is nothing but the device. Open Hardware Manager. Just click on Open Hardware Manager. So please connect the board till that point. No need to connect the connect the board. Just open the board. So connect the cable. Cable you take one cable. So it's like your mobile cables, right? Single connect. So one is at micro end and it is mobile cable. So it is in the board. The board also you have. The cable. So open hardware manager. So then power on the board. To see that how to connect on the board. So you have to remove. This is the port. This port is you remove and connect the program UART. Okay. 1 minute. You don't connect it. You reverse it, right? So power on the board. Please power on the board. Power on the board. Sir. Each port request, this port request to they will give what they want. See, once you have done, change the jumper settings. So change it to the open target. Can check the output. No? Yeah. All three are high. What is output? No, don't give it 4. Okay. 3 are high. What is output? Sum is 1. Carry is 1. So 1. See what is now? 1, 0 1 0. 0 1 0. What is the output of 0 1 0? Is 1. Carry. Like you can verify. Okay. 1 1 is what? 0. Sum is 0. Carry is what? 1. So it's like a sum and carry. Program it. So open the auto correct. Program device.
Plan ahead is different.
So plan ahead is not just
Because they have
plan ahead is the old one. All the things are same. So what is actually inside whatever is there. So this can all things are single Vivado all of they removed earlier so no need to worry about it. So now you have to call it Vivado as earlier they called it as embedded development. Now the rename it as software development. So the change is software level is more one is